Welcome to EDU World Space.
The goal of this problem is to find the perpendicular distance between the rod, the cable AB, and line of action Q vector. So I've already found the position vectors of the different points using the given figure. And to start with, we're going to find the position vector from A to B. So we have AB vector is equal to B vector minus A vector, and this will be equal to 32i minus 30j minus 24k. And the unit vector of AB is equal to the AB vector divided by its magnitude. So 32 squared plus negative 30 squared plus negative 24 squared under the square root. And this will give us a unit vector of 0.64i minus 0.6j minus 0.48k. And next we're going to find the DH vector. So the DH vector is equal to H vector minus E vector, and that's going to be equal to negative 16i minus 21j minus 12k. And the unit vector for DH is equal to the DH vector divided by its magnitude. So it's going to be negative 16 squared plus negative 21 squared plus negative 12 squared, all under the square root. And this will give us a unit vector of 0.56i minus 0.72j minus 0.41k. And next we're going to find the BH vector. So BH vector is equal to H vector minus B vector, and this will give us negative 32i plus 17j plus 17j. Okay, next we're going to write out the formula for this Q vector. So the formula for the Q vector, we have the Q vector is going to be equal to the magnitude of the force Q times the DH unit vector. So we plug in what we know. So the magnitude of Q is given, and we calculated the DH unit vector. So this is going to be 174 times negative 0.56i minus 0.72j minus 0.41k. And this will give us a force vector of negative 96i minus 126j minus 72k. And next we're going to find the unit vector of this q vector. So the unit vector q is going to be equal to the q vector divided by its magnitude. So negative 96 squared plus negative 126 squared plus negative 72 squared, all under the square root. And this will give us a unit vector of negative 0.55i minus 0.72ga minus 0.41k. And next we're going to find the angle between this q unit vector and the AB vector. So we can write it as the cosine of theta is equal to the AB unit vector dot the q unit vector. And solving for theta, we get theta is equal to the cosine inverse of this term here. So AB unit vector dot q unit vector. And plugging in what we know and taking the cosine inverse of this expression, we get an angle of 73.74 degrees. And next what we're going to do is we're going to calculate the moment of this AB rod. So the moment of the AB rod is equal to the AB unit vector dot the HB vector cross Q vector. And we plug in what we know, and we can write this as a determinant, as a matrix, and solve for its determinant. So we have the unit vector in the top row, and the HB vector in the middle row, and the Q vector in the last row. And solving for its determinant, we get a value of negative 2118.68 pounds meter. And we now have all we know to solve for the distance, solve for the perpendicular distance. So we can write out the formula. Moment of AB is equal to Q times the sine of theta times the angle D. So we know everything except for D. So we plug in everything. So this moment of AB was negative 2118.68 equal to the magnitude of Q, which is given as 174, then multiplied by the sine of theta, which theta was found to be 73.74. So the sine of 73.74 times D. And using algebra and solving for D, we end up, we write this in terms of solving for D, and we get D is equal to 12.7 inches.